Okay, hello and good morning, ladies and gentlemen. Welcome to the AWS Discovery Day, and welcome to the first webinar that we have for the AWS Discovery Day, which is called Cloud Practitioner Essential. I'm very glad that so many of you have decided to join us. This webinar is going to be pretty interesting. Essentially, this webinar is about essentially this webinar, it's an opportunity for me to tell you as much as I know about AWS Cloud in 3 hours. So if you're brand new to the cloud, if you're brand new to the AWS world, if you've maybe heard all of these buzzwords in the past, hey, cloud is good, cloud is cool, we should be in the cloud, and but you have absolutely no idea what cloud is, then you definitely came to the right place. So we're going to spend the following 3 hours together talking about cloud, talking about AWS, talking about benefits of the cloud, architecture of the cloud. Well, as I said, as much as we could squeeze in into the 3 hours, that's the plan for us for today. So one more time, everybody, welcome. A little bit about me. My name is Tomas. I've been working with cloud for over a decade now. I'm a big cloud geek. You can say that. If anybody wishes to, stay in touch and connect with me, there's a link to my LinkedIn profile. Feel free to add me there. Big cloud geek. So if you want to keep the discussion going after the cloud, or perhaps if you might have, any questions, feel free to add me there, and I'll be super happy to answer any questions that you might possibly have. So that's me, Thomas. I'll be your presenter for today. Now, I know it's cloud. I know cloud is good. Cloud is cool. That's the topic. What we'll be talking about today. But why is cloud good? Why is cloud even necessary? I'm sure if you're from the IT background, if you've been working in this industry for quite a while, I'm sure you've been there. You've been in the situations where you had a cool idea, for a product, for a service. You wanted to provide it to your customers, and now the planning period started. So you've got an idea. You want to provide some products or services to the customers. Now you have to make some estimates. Okay, how many customers are you potentially going to get? What's the quantity of the product or services that the customers potentially want? Now, based on that estimated quantity, now you have to estimate, the resources that you need. Maybe you need 25 server, 5 databases, and some other hardware, etc. So you need to make a lot of estimates. Now you need to start a procurement process. You need to order stuff, you choose a vendor, etc., etc. So essentially, you have to spend months of planning, preparing, having everything installed, delivered, etc. Then you can finally run, your idea. You can finally start offering your products and services, only to find out that, maybe you've underestimated the demand. You have much more customers interested in your product, but you cannot offer it because you don't have enough capacity. Or perhaps the other way around as well. So maybe you've overestimated the demand for your customer. Maybe not that many customers are interested in that. So now you've got, so much hardware that's sitting there doing absolutely nothing for you. So this is of course true for any hardware, any server, storage, databases, whatever you've ordered. As maybe you're good at it. You've been around in the industry for a while, so you can make some reasonable estimate. But it's always going to be an estimate. It's never ever going to be. It's never ever going to be right. So you will most likely always find yourself in the situation that you have too much stuff, or you don't have enough. That's one of the benefits that cloud is going to bring for us. Essentially, if you want to talk, if you want to get the official cloud definition, if you're curious about what a cloud even is, you can essentially imagine cloud as any IT resource, any IT service, hardware, software, servers, databases, programming, AI, networking, absolutely any IT resource, absolutely any IT service that you can get. You can get to this IT resource and service through the internet with pay-as-you-go pricing. So it's kind of like the very nice, the Wikipedia definition, if you will. So cloud is on-demand delivery of IT resources, services, and application through the internet with pay-as-you-go pricing. So whatever you need, whenever you need it, you can get it. Do you need 5 servers right now? Okay, one click of a button, you get 5 servers right now. Do you need 5,000 databases right now? Again, the same thing. With just one click, and you're gonna get the 5,000 databases right now. How long do you need it for? Do you maybe need it for only a few hours, few days, weeks, months? It doesn't really matter. With the cloud, we usually have the pay-as-you-go pricing, meaning we turn it on, we start paying for it, then we turn it off and we stop paying for it. And we've only paid for the duration that that particular resource has been used. So again, imagine the traditional on-premise environment. Typically, we have a pretty long-term contracts, 5, 10-year contracts, etc., etc. With cloud, we've got a full flexibility, no long-term contract. Turn it on right now, start paying for it. Whenever I don't need it anymore, turn it off and I will stop paying for it. So that what a cloud is, what we can get in a cloud. As I said, essentially anything that you can imagine from the IT world, any server, any resource, anything that anything that you can imagine, you can get it. You need servers to run your application, absolutely. You need storage services, absolutely. Do you need databases? No problem. Do you need applications? Do you need any other services that we don't have on this slide? Maybe some AI services, machine learning services, IoT services, and the list goes on and on and on. Currently in AWS, we've got over 200 individual services that you can choose from. So trust me, whatever you might need, whatever that cool idea that you have, that service, the product that you need to implement your idea, most likely you're going to find it in AWS. So maybe you're excited about AWS. Now, how we can actually integrate cloud into different organizations. What we see on the slide are 3 different deployment models. Usually, most customers start all the way to the right, so in the on-premise deployment. So in on-premise deployment, you have your own facility. In your own facility, you have your own resources. Maybe you have your own data center. So you're running everything in-house. You've got staff to support it, and everything is over there. Now, if you want to start a transitioning process, most likely you will not be able to do this kind of like a big bang, like turn everything on, one place and turn everything on the other place at the same time. Most likely for some time period, you'll find yourself in a hybrid environment. So in a hybrid environment, we're still going to keep the on-premise facility. We're still going to have some, applications and services running in our on-premise facility, but we're going to connect our environment to the cloud, infrastructure. So we're going to start migrating, transitioning applications from our on-premise environment to the cloud world. So for some time period, we'll now be running both environments. We'll be running cloud environment and on-premise. Maybe this is going to be the end goal. I know that some customers, are happy. Some customers might have some needs, why they want to keep some resources in an on-premise environment. So that's fine. So maybe this hybrid environment, this is the final stage for you. Or maybe you want to take it a step further and you want to run all your applications and services purely from the cloud environment. Essentially, this would mean the decommissioning that on-premise facility, selling out all of the hardware, software, everything that you had, and running all of your applications purely from the cloud. So you've got 3 different deployment models. So we spoke a little bit about a cloud. You know what a cloud is, but we haven't spoke that much about benefits. So why do we even want to go to the cloud in the first place? What we have in this slide are 3 major benefits recognized by AWS. Let's actually start from the left because, or maybe no, let's do it differently. Let's start from the kind of like from the middle because the benefit that most of the customers that I know usually say as number one, the benefit that everybody wants to write down in their business plans, that's the cost saving. So I know we live in a very competitive world. We need to stay ahead of the competition, or we need to save as much resources as possible so we can invest these resources in other initiatives, other projects, other activities, other services, etc., etc. So the idea while we go into the cloud would be to save as much money as possible. Although this may sound super tempting, yes, everybody wants to save money. Yes, everybody, wants to have everybody wants to realize some nice saving. In reality, this is probably not going to be the most important benefit that we get out of cloud. Most likely, when we're going to see the most business value from the cloud is going to be in agility and elasticity. Again, we live in a very, very competitive world. I'm sure that whatever industry you're in, it's probably going to be quite a few of very, very tough competitors. The only way for us to stay relevant in this very competitive world is to be the best. So is to continuously offer the best products and services for our customers. If you want to do that, if you want to continuously keep offering the best possible products and services for our customers, we need to be agile. We need that elasticity. We need to be able to operate quickly. If we have an idea, we need to be able to implement this idea very, very quickly. Imagine the situation that you have a really cool idea for the product without all of the benefits of the cloud. If you have to, do the estimation, order some equipment, and spend months and months, getting everything organized, most likely your competitors will going to beat you to it. So with the cloud, we've got this amazing agility and elasticity. You have the idea, you need 25 servers right now, one click, in a minute, in a couple of seconds, you're going to get your 25 servers. If you realize that, maybe 25 servers, that's not the right number for you, you need 26, again, one click, you're gonna get additional server. Or maybe if you've overestimated, if you need to lower the number of resources, again, absolutely not a problem. One click of a button, and you can decommission some resources. By the way, I'm saying click of a button. Obviously, with cloud, we can put automation in place. So that's again one of the major benefits of the cloud. We can actually have our infrastructure automatically growing, expanding, or shrinking based on the demand. So we have access to the cloud services that can automatically scale our resources based on the demand. So that's the true elasticity and true flexibility. So agility means faster innovation. Agility means not waiting for any additional resources. Agility means our ability to experiment and innovate. Agility also means that everything is happening automatically. So getting more resources or decommissioning resources, it can happen in the middle of the night. You can still, be sleeping in your comfy bed, and your infrastructure can be working automatically for you. Getting more resources, decommissioning resources, all of that's happening in the background, fully automatic, no user intervention required. Elasticity, it means again our ability to adapting to various workload, whatever the workload is, whatever the idea is, whatever the product or the service is, you can get the required resources from AWS 24/7. We've already talked about this idea of elastic infrastructure. So nothing is, set in stone. Everything can work automatically for you. So you will always have, just enough resources to make all of your customers happy. And at the same time, you will never have, more than enough resources. So also you can, save your wallet. Don't worry, you will not have to pay for anything that you don't need. Cost savings, I've already mentioned it. That's usually the benefit that customers put first, in most of the business plans that I've seen. I know, I understand it. That's usually a very good way how to write a business plan, is to save. We're going to save, I know, 20% of our infrastructure cost, as an example. While this might be true, certainly, if we architect things in AWS, if we architect things with cost in mind, which is something that we should always do, it is definitely possible to save up quite a bit of money, in comparison with running a traditional on-premise facility. However, as I said, usually at the end, ability to offer amazing products and services, usually this will brings us a little bit more value than simply cost saving. So keep cost saving in mind. Nothing wrong about cost saving, but maybe think about all of the opportunities and possibilities that the cloud brings. So it's not limited just to saving up a little bit of money. And the last one is the rapid deployment. So with AWS, we've gotten access to highly scalable platform that's spread all over the world. AWS operates data centers, all habitable continent. So anywhere your customers might be, you can provision your resources there. So you're close to your customers, so your customers have the best possible experience. Speaking about AWS global infrastructure, on the map, we've got AWS global infrastructure footprint. So the AWS global infrastructure footprint is divided into regions and availability zones. What we can see on the map are current AWS region. What a region is, maybe you're asking that. So region is a separate geographic location with multiple facilities inside that geographic location. If you're from the US, for example, we've got North Virginia as a region. If you're from South America, we've got Sao Paulo as an example. If you're from Europe, we've got Frankfurt. If you're from Australia, we've got Sydney, etc., etc., etc. So anywhere that you might be from, most likely AWS is operate a region close to that geographical area. That region is always named based on that geographic area, so we always know, where that region are, and we can start provisioning our resources from inside that region. Now, every single region, inside every single region, you will always find several clusters of data center. So, for example, we have a region, let's say Frankfurt in Europe, and inside the Frankfurt region, I'm going to find usually at least 3, sometimes more, clusters of data centers. These clusters of data centers, they're called availability zone. Each availability zone is fully isolated from one another. Meaning it has its own, internet, electricity, etc. And at the same time, they're all connected using private AWS high throughput networks. So the idea behind availability zone is, since each availability zones is isolated, meaning should there be some problem, in a single facility. We can imagine some technical problems. Maybe there are some natural disasters, tornadoes, hurricanes. I don't know. So it is theoretically possible that that particular facility or that cluster of facilities might be temporarily offline. However, this should not really present a problem for us because the idea behind it is that we should spread our workload across all of these different facilities. So we should use multiple availability zones in our architecture. And if that situation happens, any problems with a single facilities, if we've spread our resources across, not a problem for us. Our application can stay functioning, our customers can still use our products and services, and everybody can be happy. So this is what I just presented. This is the idea behind highly available and fault-tolerant infrastructure. That's something that we should always architect in AWS. In addition to AWS regions, we've got about 30 AWS regions. We've got hundreds, we've got 100 plus availability zone. So in addition to all of the regions and availability zone, we also have 500 plus points of presence. Essentially, imagine this point of presence as a small AWS data center. AWS tries to build this small data center in close proximity to any bigger metropolitan area. So essentially, anywhere there's a cluster of people, there's a big group of people living there, AWS will try to build this, which is called edge location. So this point of presence, this is a small data center. And we can use all of these 500 plus edge locations. Typical use case is to provide caching, so we can cache our data locally in these facilities. So now when the customers are accessing our products and services, obviously, if the data is cached locally in any of these facilities, customers can access it much faster versus if the data would have to be transferred across the oceans, thousands of miles. So AWS edge locations, over 500 of these edge locations, and the typical use case would be for caching data or quicker access to AWS network. So getting data out of AWS, cache data, or sending our request to the AWS network as quickly as possible. These are the two typical use cases of edge locations. So I know I've talked about a lot about AWS. Probably the key takeaway from this part of my presentation would be that AWS cloud provider on-demand delivery of IT resources and services through the internet with pay-as-you-go pricing. Major benefits why we want to consider AWS or cloud in general would be to be able to offer the best possible products and services to our customers. So our agility and elasticity. Rapid deployment, it's always good. So we can do these things. We can develop these products and services as quickly as possible. And obviously, at the end of the day, everybody wants to save out a little bit of money. So cost saving is another major benefit of AWS. Okay, so ladies and gentlemen, that's the end of the introduction to the cloud. So hopefully now everybody has slightly better idea, what a cloud is, what we can expect from the cloud. For the remainder of this webinar, what we'll be doing is talking about the core components of the cloud. So I know I've mentioned, there are over 200 individual services in AWS. So as you can imagine, unfortunately, we do not have time to go over all the 200 plus services. But what we decided to do instead is to choose the most important ones, to choose the services that are most commonly used by most customers, and we're going to talk a little bit about them instead. So buckle down. Now we're going to start our discussion about most important cloud services. Of course, we cannot start our discussion about the most important cloud services without talking about compute. So the first domain we're going to be talking about is compute services. When it comes to compute services, there are actually several individual compute services. Again, on the slide, we're not able to cover all AWS compute, but we've put the most important ones instead. So what are we talking about is web servers. So if you want any web server, any operating system, any size and shape, that's something we can get from AWS called EC2 instance. We will also be talking about how we can actually scale the capacity of these instances. Imagine that you want to have a cluster of these servers and you want the cluster to automatically add additional nodes or remove some of the nodes based on the demand. So we'll be talking about that. Then we will be talking about load balancing, meaning how we can have some sort of component that will be sending, that will be routing our request to this, ever-changing cluster. So we'll have a component that will always know exactly how many nodes are in the cluster and will distribute the traffic across all of them. Then we will talk a little bit about containers. You've heard about containers, one of the most used word nowadays. Everybody's interested in containers, Docker containers, possibly Kubernetes as well. So we're going to talk a little bit about that. And finally, probably my most favorite part of AWS Cloud, we will cover a little bit of serverless computing. So essentially, serverless computing will present us the option to leave all of this management, all of this administration, installing, patching, updating, scaling, securing, and we can go on and on. So all of these administrative tasks to AWS, so we can truly focus on what matters. We can truly focus on bringing the best possible services and products for our customers. So this is going to be the last component, AWS Lambda, piece of serverless computing. All right, so as promised, the first thing we'll be talking about are EC2 instances. EC2 instances are essentially, you can imagine EC2 instance as a virtual server. So I'm sure you've ever seen a server, like a physical server, the big box with all the hardware inside. With AWS, we don't typically get real physical equipment, but we always get virtualized resources. So virtualized resources, virtualized services, this is what we get in AWS. These virtualized resources and virtualized services can be for absolutely any use case that we might have. For instance, why do you want to need a web server? Well, maybe you've got a cool application you want to run on it. So maybe let's add the custom. So any custom application that you have, you want to run. Sure, maybe you want to do a little bit of a high performance computing, absolutely fine. You want to do big data analytics, you want to run some batch jobs, etc., etc., etc. Essentially anything, any application, any service that you want to run. If you need a server to run it on, you can get it. And in AWS, it's called Amazon EC2. So if you're curious why EC2, EC2, it stands for Elastic Compute Cloud. So we've got a word compute, so we can get the compute power. And we also have the word elastic, meaning that we can actually get the EC2 instance in any size and any type that we want. Do you want perhaps a certain version of a Linux operating system? Absolutely fine. Do you maybe want a certain version of Windows? You can get it. Maybe do you want a certain versions of Mac? You can absolutely get it as well. So regardless of whatever platform you want to have and whatever size you want to have, maybe you just want something that's very small, very cheap, or maybe you're running some, let's say, big data analytics workloads, so perhaps you need something with a GPU chip, something of reasonable size. You know, whatever the requirement is, there are hundreds and hundreds of sizes to choose from. So you can get the type and size of EC2 instance that you want. Using EC2 instance, it's absolutely fantastic. I don't think it can be any easier. You just go to the AWS console, you select something which is called AMI. AMI stands for Amazon Machine Image. This is essentially the template that AWS will use to create the EC2 instance for you. So just imagine that just imagine like, you know, like a flash drive with the operating system and some application, etc. So of course in AWS everything is virtualized, so we're going to create this virtualized template. So this is the template that AWS will use. So we grab the template, we select what size do we want. Small, we've got hundreds of different sizes to choose from. We specify some additional configuration, and typically in a matter of tens of seconds, sometimes maybe a minute, we can get our EC2 instance. When we get our EC2 instance, AWS will give us the keys. So we'll have the admin keys to the EC2 instance. We can log into the EC2 instance, and we can do absolutely anything that we want. We can install any platforms, we can install any application, we can do any OS level configuration. We'll be given the keys, and we can do absolutely anything that we want with it. So when it comes to how are we going to pay for the EC2 instance, I already presented the idea of this on-demand mode. If you remember, when we're talking about the cloud, the definition of cloud, so one more time, cloud is the providing of any services, any applications through the internet with pay-as-you-go pricing. So this pay-as-you-go pricing, this is what's called on-demand instances. Very simple, very straightforward. Essentially, we turn it on, we start paying for it, we turn it off, and we've stopped paying for it. And we've only paid for the duration that the instance have ran. So if the instance ran for 5 hours, we paid for 5 hours. If it ran for 5 days, we paid for 5 days, etc. So we've got no commitment, turn it on, start paying, turn it off, stop paying. As simple as that. Sometimes, however, if we actually can make some sort of commitments to AWS, if we can make 1 or 3 year commitments, AWS can give us a very significant discount. The discount is between 60 to 70%. So with commitments, that's something which is called reserve instances or saving plans. There are different models. The idea is the same though. So I make a commitment to AWS, 1 or 3 year commitment, and now I get that particular resource about 60 to 70% cheaper. So very nice thing. There's also one more purchasing model for EC2 instances, something which is called spot instance. Spot instance can be very, very interesting. Essentially, spot instance is the leftover capacity that AWS has in any data center around the world. As you can imagine, sometimes if AWS has a lot of leftover capacity for certain type of EC2 instances, AWS can offer this capacity with a great discount. The discount can go sometimes up to 90%. So very interesting model. If we want to utilize these discounts, we can just look for some leftover capacity in some AWS locations, and we can get them at a really, really good discounts. So these are the 3 major purchasing models for EC2 instances. Now, as we said, starting a single EC2 instance is very simple. We just go into the web console. or perhaps we can do it automatically from our code. So you're developing application, we can start it from the CDK, or maybe if you're a fan of scripting, you can run a little, you can write a little bash script or PowerShell script to do that for you. Regardless, so starting a single EC2 instance and stopping, potentially terminating, is very easy. Now, what can you do if you actually don't want to do that? You don't want to have a single EC2 instance, but what you'd rather have is a cluster of EC2 instances, ideally a cluster that's actually spread across various AWS availability zones. And you actually want this cluster to be automatically expanding if you have a lot of demand, or automatically shrinking if you don't have that much demand. So if you want to do that, and if you do not want to do it manually, if you don't want to wake up in the middle of the night and having to start a new server or terminate a new server, don't worry, that's absolutely not necessary. We can use another service, which is called Amazon EC2 Autoscaling. So Amazon EC2 Autoscaling is a service that will automatically add additional nodes in the to the cluster if we have a demand for it, or at the same time it can automatically remove nodes from the cluster if our demand is not so high. So that's Amazon EC2 Autoscaling, is the service that can add flexibility into our infrastructure by doing all of this automatically. This is also the service that can actually add high availability and fault tolerance for the to our infrastructure, because our cluster actually do not need to reside in a single availability zone, so in a single AWS data center, but the EC2 Autoscaling can actually automatically start, can actually automatically add these new nodes across all of the different AWS facilities in a given region. So EC2 Autoscaling can automatically, add nodes in all of these different facilities. Should there be a problem with a single facility? Not a problem for us because we have our infrastructure divided across all of these different facilities. So great service. It adds elasticity, it adds fault tolerance, and it adds high availability. Really good news about the service. Actually, the service EC2 Autoscaling is free. So if you're worrying about paying too much money, do not worry. We can use EC2 Autoscaling absolutely for free. Obviously, we still have to pay for the resources the service will provision, but the service itself is free. Before I presented the idea, so this is the idea of always having just enough. So you have a demand, imagine that you have a web application, you need the servers to support your web application. Obviously, if you have more customers coming to your application, you're gonna need more servers. If you have some quiet period, maybe it's a middle of night, everybody's sleeping. So for the quiet period, you do not need to pay for that many servers. So again, the service can automatically scale down our infrastructure. So essentially, it's going to look exactly like this. The blue part on this graph is the demand, and the autoscaling group will automatically provision appropriate number of server based on the demand. So on this slide, we actually have presented this idea of not using autoscaling. Essentially, if we don't have this amazing service, if we don't have elastic infrastructure, what we have to do, we always have to again make estimates and kind of provision our infrastructure for the peaks. So without this service, if you think you're potentially gonna need up to, let's say, 10 servers, you're gonna provision 10 servers, regardless of perhaps right now you only need 1. However, with the service, as we've already talked about it, we can be automatically adding or removing servers, removing nodes in our cluster based on our actual needs. So not any predictions, that somebody did with the Excel spreadsheet. No predictions whatsoever. right now, this is my demand right now, and this is the number of server that I need right now. And this is what we're gonna get from EC2 autoscaling. A little bit about terminology. So if you want to use the surveys, we're gonna create what's called EC2 autoscaling group. So we're gonna create autoscaling group. Imagine autoscaling group as the cluster of a node, so cluster of EC2 instances. For the autoscaling group, we're always going to specify the minimum. So this is the minimum number of nodes that we'll always want to have in our cluster. Perhaps if you know that your application needs at least 2 servers to run, you can specify minimum 2, minimum 1, or maybe minimum even 0 if you have know them, you don't want anything. So minimum, that's the minimum number. Then we can specify the maximum number. So this configuration will tell the autoscaling, okay, you can add up to X, number of nodes. For instance, and so here we've got minimum 1, we've got maximum 4. So the autoscaling group will always keep certain number of instances between 1 and 4, and that number will be based on the actual demand. So it will be based on the actual needs of your application. One last thing that you have to specify is the desired configuration. So the desired, this is the starting point. So for us, the desired is 2. So you're gonna say, all right, so start with 2. If you need to add more, you can go all the way up to 4. If you need to remove some, you can go down all the way up to 1. Obviously, just an example, you can put whatever value makes sense for your application. Sorry. So you might be excited. So now we have, a service that can automatically add or remove resources according to our needs. The problem we might find now is, how are we actually going to target the traffic to these resources? Imagine you have an application. The application is using, EC2 instances as a backend. But now, how are you going to send, requests from your application if you don't know, well, do I have 1 instance right now? Do I have 2, 5, 10? I have no idea, how many instances do I have now? That's the responsibility of the autoscaling. Don't worry, AWS got you covered. So the component that we use very, very frequently with this elastic architecture is another service, which is called elastic load balancing. Essentially, you can imagine elastic load balancer as a single point of contact for all of your incoming web traffic from all of your applications. So now I'm going to have this elastic load balancer. I'm going to have this single point of contact. So my website, my web application, whatever you have, I will send a request to this single point of contact. So everything is sent to one place, so that's easy. And whenever traffic reaches Elastic Load Balancer, since Elastic Load Balancer is greatly integrated with the autoscaling group that we've talked about in the previous slide, the load balancers knows anytime exactly how many nodes there are in the cluster, and is going to equally distribute the traffic across all available targets. So let's imagine there are 4 nodes in a cluster. So first it goes to the server 1, then 2, then 3, then 4, then again 1, 2, 3, 4, again 1, 2, 3, 4. So it's going to equally distribute the traffic across all available targets. The targets, so the EC2 instances, as we see, they can be spread across AWS availability zones, so across AWS facilities. So this is great because this is exactly what the what the EC2 autoscaling can do for us. So EC2 autoscaling is going to is going to create these EC2 instances across availability zone. That's great. So now we have the fault tolerance and high availability. And Elastic Load Balancer can also send our traffic to all of these instances across all of these availability zone. So we've got a great integration of these services. Maybe there is one more feature that I should mention about the load balancer. The load balancer will also do health checks. So load balancer will automatically do health checks, and load balancer will only send traffic to healthy instances. So, things go wrong. In IT, things go wrong all the time. Sometimes, some nodes in your clusters, some EC2 instances might become unhealthy. Not a problem. The load balancer will automatically discover that because it's doing health checks. And if there is anything unhealthy, it will stop sending traffic there. Actually, the automation goes further because then our auto-scaling group will automatically terminate that particular EC2 instance and get a new one instead. Again, all of this behavior is fully automatic. So how is it going to look like with the load balancer? As we said, so this is the ELB. So this is that elastic load balancer. So this is that single point of contact for all of this incoming web traffic that we have. All right. So all of our customers, if customers go on website, web applications, mobile applications, whatever you might have, the target for all of these applications will be that one single elastic load balancer. And on this slide, we've got this idea of this combination of using elastic load balancer and auto scaling group together. So we've got an elastic load balancer. So we've got a single point of contact, single component where everybody sends the traffic into. Now this elastic load balancer is integrated with auto scaling group. So the traffic goes to the load balancer and the traffic is sent to the first available instance. Second request, it's sent to the second instance. Third request, again to the first instance. Fourth request to the second instance, etc., etc., etc. And since we have this integration with elastic load balancer and auto scaling group, as we said, auto scaling group will automatically add or remove instances from our cluster based on the demand. So that's why we have the situation on the right. If we have a busy period, I don't know, imagine Black Friday shopping, something like that. We have a busy period. Our auto scaling group, as we saw, as we can see, has automatically added additional nodes. So previously we had 2. Now our auto scaling group automatically added additional 2. So now we have 4 nodes in our cluster. And what we have to do, from the administrator perspective, absolutely nothing. All of these adding additional nodes was fully automated. It was automatically done by auto scaling group. We still have the same elastic load balancer, so we still have the same single point of contact, the same component that all of the incoming traffic is sent to, and now the elastic load balancer will distribute the traffic to these additional nodes. So now again, the work is equally divided across all available targets. When it comes to elastic load balancers, there are actually several to choose from in AWS. So now we'll be talking about types of ELB, so types of elastic load balancers. The first one, probably the one that's most commonly used, the one that offers the most features and services. It's kind of like a go-to choice unless you have a specific requirement why you shouldn't use this one. Usually this one is the one to go with. It's called application load balancer. So the application load balancer is great for any kind of HTTP or HTTPS traffic. So any kind of traffic out there in the internet. This is why I said this is the default. This is why it's the default choice, because most likely any modern application will be very happy to use HTTP or HTTPS. So that's why this load balancer, that's usually the one that we that we choose from. The load balancer, it operates on this HTTP level. So if you did some networking classes at university, this is the level 7 in the OSI model. And the load balancer, as I said, offers the most comprehensive, this application load balancer offers the most comprehensive set of features. For instance, this application load balancer can route requests based on the URL. So if somebody goes to example.com/users, it can go somewhere. If somebody goes to example.com/registration, it can go somewhere else. So we've got this path or route-based routing. So this is the example of how we can use this path-based routing. Again, imagine here we've got the client application. So we've got our customers, sitting behind a computer on our website or maybe on our web application. The request, as we said, will go to this single point of contact. So the request will be sent to the application load balancer. An application load balancer based on the path that user click on. One more time, imagine that somebody click on example.com/images. It can go to a certain EC2 instance. If somebody clicks somewhere else on a different link or use a different button, it can go to different EC2 instances as well. So this was the application load balancer. As we said, there are many other load balancers for different use cases. So just the application load balancer was one of the examples from the load balancer family, the one that is most commonly used. Let's actually leave the EC2 instances for a while, and let's explore how AWS can help us with containers. So maybe you're familiar with containers, probably you've heard about containers. That's something that, in IT, everybody's talking right now, how to run some, Docker containers, or how to do, perhaps how to run Kubernetes as well. So if that's something interesting for you, if containers are interesting for you, and you're looking for a place to run containers in AWS, we do actually have several fully managed services. One example of the fully managed container services, it's something just called ECS. It's Elastic Container Service. So Amazon Elastic Container Service is a fully managed, high-performance container management system. So if we want to run Docker containers, you want to run Docker-enabled applications in AWS, and you don't want to worry about, creating your own EC2 instances, installing Docker, patching Docker, updating Docker, spreading containers across all of these EC2 instances, etc., etc., etc. If you actually want AWS to do all of that for you, so you want a fully managed container service where actually the container is provided for you and it's managed for you by AWS. If you want to have that, go ahead and check out Amazon Elastic Container Service. I should definitely point out that this is not the only AWS container services. If you're interested in running Kubernetes, there's also a different container service, which is called EKS, Elastic Kubernetes Service. So with containers, we've got two different services, ECS for running Docker containers, and we've got EKS for running Kubernetes in AWS. If you're not familiar with Kubernetes, Kubernetes is an open source orchestrator, very popular solution nowadays. So if you're interested in this open source orchestrations, we also have a service for you in AWS. All right, and one last service from this compute section, probably my most favorite AWS service that I use most commonly, and also I'm sure there are a lot of customers that are super happy with the service. So the name of the service is AWS Lambda. So AWS Lambda is a service that will enable us to run our application without provisioning, managing, without actually thinking about servers. So the only thing that we have to do if we want to run our application with AWS Lambda is to actually write that application. So we still have to write that code. There are plenty of popular runtime supported out of the box if you have Python application, Java application, .NET application, etc., etc. So whatever your application is, you just grab your code, upload the codes to AWS, specify some configuration. Most important one is the trigger. Trigger being that that event that should start the execution of your application. I don't know, it can be, you know, somebody clicks a button, somebody presses something in your mobile app. It can be absolutely anything. So whatever the trigger is. And now, whenever that event happens, you know, whenever somebody clicks a button or clicks a link or something like that happens, now AWS will automatically run your code. The biggest beauty about it is it's a fully managed service, so we don't have to think about, okay, where the code is run, on what server is it run, how do we scale it, how do we patch it, how do we secure it, how do we install, etc., etc. All of that is handled by AWS. So from our perspective, essentially we just have to write a code, specify some configuration, and that's it. Everything else will be handled by AWS. One of the biggest beauty about the service, so with AWS Lambda, we will only pay for that compute time that we used while our application was running. So if you create a Lambda function and if nobody's, you know, clicking anywhere, if your code is not being executed, you will pay exactly $0. Actually, even if you have a little traffic, even if your Lambda functions are being a little executed, you know, executed a little, you will still pay $0 because AWS Lambda is part of the free tier. So every single month you have a certain number of executions, certain compute time for free. Obviously, if you go above that, then you will pay for that compute time that your application used, but every single month you will have a certain number of that for free. And also AWS Lambda is integrated with all other AWS services. So if your application needs to use any other AWS service, absolutely possible. We've got a great integration with the REST AWS ecosystem. So how is it going to work? You're excited about Lambda, you want to use it. Well, let's get to it. As we said, unfortunately, you're still responsible for that code. So you still have to write that amazing Python code, Java code, .NET, etc., you know, whatever programming language your application might be. I know nowadays there are some AI services, you know, that can help us significantly. If you actually developers, definitely do check out a service which is called AWS Code Whisper. So AWS Code Whisper is the AI service that can automatically write some code, like parts of the code for you. It's super, super cool. Essentially, you just write a command, and then based on the command that you write, AWS will generate the block of code for you. So really, really cool service. However, writing the code, that's still something for us to do. So we've got a code. We've uploaded the code to the AWS Lambda. Now we have to specify the trigger. So when exactly do we want our Lambda to run our code? Again, maybe it can be, you know, somebody clicks a button somewhere. Okay, so we specify the trigger. We specify some additional configuration for Lambda. And now Lambda will be sitting there idle, costing us $0 and waiting for, you know, somebody to click that button, waiting for that event, for that trigger being initiated. So whenever that trigger happens, now AWS Lambda will automatically run our code, and as we said, we will only pay for the actual compute time that we've used. This is absolutely fantastic from the pricing perspective, because when you imagine EC2 instance, the web server we've talked about recently. So the EC2 instance, we pay for the time the EC2 instance is running. So we start EC2 instance, we start paying, and then when we stop it, we stop paying. However, during the time that the EC2 instance was run, did we actually use the 100% of potential of EC2 instance? Most likely not. Usually we have a very little utilization from our EC2 instances. Maybe we only use like 10, 20, 30% of the potential capacity of that server. However, we still pay exactly the same for it. We pay for the duration of that particular EC2 instance. That's why when customer actually migrate to AWS Lambda, possibly container, usually they can realize a dramatic cost saving, because now we're not paying for that unused capacity that we could have used but we didn't, but we're only actually paying for what we've actually used. We're paying for that compute time that we've actually used. So that's why the Lambda function can be migrating to Lambda function can save us quite a bit of money. All right, so ladies and gentlemen, I know we talked about for an hour actually now, and there's still a lot of topics I want to talk about. What I would suggest right now, why don't we take a 10 minutes break? So if you still haven't finished your breakfast, coffee, etc., feel free to do that. It is 10:30 Eastern time. So why don't we come back at 10:40? Eastern time. So if you're in a different time zone, then it's going to be 20 to whatever, so 10:40. So please enjoy this little break and be sure to come back, because there are still a lot of cool services to discuss. So thank you for now, and see you all in 10 minutes. Okay, so ladies and gentlemen, hello and welcome back. Hopefully you've enjoyed a little break. And I'm so glad that you're back with us because we still have a lot of really cool services to talk about in AWS. And where we're going to continue from our compute module is a storage section. So now we'll be talking about several AWS storage services. Similarly as with the previous one, again, there's plenty in AWS to choose from. So again, we've just selected the biggest, the most important storage services. Of course, in addition to the services that you see on the slide, there are also other storage services in AWS. So a couple of things we'll be talking about in this section. First, we're going to start with one of the most AWS popular service, which is called Simple Storage Service, or S3. Then we're going to move on to the storage for our EC2 instances. So if we need like a virtual hard drive for our EC2 instances, we can get it with Amazon EBS. Then we've got two services. If we actually don't need a virtual hard drive that's attached to one instance, but if you actually need like a file system that can be simultaneously accessed by thousands of our EC2 instances, we've got two services for that. We've got EFS and FSX. All right, so a lot of three letter abbreviations. Let's start to untackle them a little bit. So as promised, we'll start with a service that maybe you've heard of. It's one of the most popular AWS services. Sorry, and it's called Amazon Simple Storage Service, or abbreviated as S3. So S3 is a scalable, durable storage service that will allow us to store any number of objects. Essentially, imagine a file, any binary format, pictures, images, video, audio, log file, whatever you might have, any files that you might have, and you can store an unlimited number of them in an S3. So S3 is an unlimited storage service. So that's great. We can store unlimited number of objects. That's awesome. Now, S3 has been designed for 11 nines of durability. This is absolutely fantastic. This is something that you will very, very, very rarely see it in the IT world. 11 nines of durability. Imagine, all of these SLAs like 99.9, etc. With AWS, it has been designed for 11 nines of durability. If you wanna, if this is hard for you to imagine, it essentially means that if you store 100,000 file, you can expect to imagine a single one of these 100,000 every 10 million years. So this is what 11 nines of durability translates into the real world. With S3, also S3 supports various use cases. As we said, maybe you want to store some data for your website, some content from our website, pictures, images, video. Maybe you want to store log file. Maybe you want to create like a data lake in S3. You have some big data workloads, etc., etc., etc. There are thousands and thousands of use cases why we might want to use S3. Also, with all of these different use cases, some data will be accessed frequently, maybe every day, every hour. Some data, like some archives, will be there for years and centuries, and maybe they won't be accessed at all. So also with S3, we've got various storage classes. So whatever our use case is, it will always be cost effective for us. A little bit about terminology. So in S3, we store files in buckets. So essentially, you can imagine bucket as some sort of like a container or a repository. So first, we have to create a bucket. We have to specify a region for the bucket. We can create buckets in any AWS regions. And now after we've created bucket, we can store unlimited number of objects, as we said, to this bucket. There's a certain limitation. The limitation is for the size of a single object. So single object can be up to 5 terabytes. That's the limitation we have. But we can store, potentially unlimited number of these up to 5 terabytes objects. Also, S3 support. Also, S3 offers us plenty of really cool features. For instance, one of the features is versioning. So if you want to prevent, accidental deletion, anytime somebody uploads, deletes an object with the same name, it will be saved as a new version. We have accidental deletion prevention. We have event notification, which is an automation, so we can run some automation in S3, and we've got additional features as well. So S3 is a very, I'm sorry. So that's all about S3. Now, a second storage service we'll be discussing is something which is called Elastic Block Store, or commonly abbreviated as EBS. So EBS will provide us a block level storage. If you're familiar with the block level storage, it's essentially a storage for your just imagine the laptop that you're on right now. Inside your laptop, you're going to find a hard drive, probably some SSD drive. This is essentially it. So that SSD drive in your laptop, that's the block level storage. In AWS, we need to get exactly the same thing. Obviously, as we're talking about, our EC2 instances, our web servers are virtualized. So again, we're going to need a virtualized storage. So whenever we need a storage for our EC2 instances, we can get it, and the name is EBS. EBS is highly performant storage. Again, we can get any size that we want. There are plenty of different performance categories, so whatever performance we want, we can also get it as well. So whatever size, whatever shape, whatever performance we want to get it, we can get it as well. The big beauty, since this is actually a dedicated service, it's a virtualized storage, we can scale that storage however we want. So this is fantastic. And we can also potentially do the virtualized service. We can actually detach the storage from our EC2 instance, and we can attach it to another EC2 instance if we need. So we've decoupled storage and compute. So if you need to detach it from one EC2 instance and attach it to a different one, it is absolutely possible. When it comes to different categories, as I said, sometimes we need something super fast. We're happy to pay for it. Sometimes we just want something that's as cheap as possible. Essentially, these are the categories that we can see in the list. We have the SSD categories. So these are going to be for majority of our workload. We have the channel category for typical workload. We have the provision IOPS for workload that requires very high performance. And then we still have the traditional, spinning plates, if you ever saw that. So this might be quite interesting if you want to store a lot of data. Potentially imagine that you have a very large data warehouses. You don't really care about performance that much, but you want to have it as cheaply as possible. So whatever the use case is, whatever your requirement is, again, you can find optimal solution in AWS. So this is how it's going to look like. We have our EC2 instance, and to this particular EC2 instance, we've attached a single EBS volume, certain type and certain size. We have a different EC2 instance, and to this different EC2 instance, we've attached two different EBS volumes. Again, whatever type and whatever size we want. So this is great. We've got EBS that's attached to one instance at a time. We can actually, what we can potentially do, imagine that we want to detach it, this EBS volume from this EC2 instance, and attach it to this one. So this is absolutely possible, single API call or click of a button, and we can do that as well. So let's go. We've got EBS that's detachable. We can attach it somewhere else. But what about if you need actually like a central repository? If you need like a central place where everything and everybody can access, so you can store files and you can share them with everything and everybody. If that's the case, don't worry, AWS has got you covered. You can actually use the service which is called EFS. So EFS is very similar to EBS, as we've talked about in the previous slide. It's only one letter difference in the acronym. Essentially, you can imagine EFS as like an EBS volume, but this time it is actually attachable to any EC2 instances that you have. So if you want a simple, scalable, centrally shared file system that can be attached to thousands of EC2 instances. It can also be attached to additional AWS services such as Lambda functions, containers, perhaps also on-premise resources as well. So if you truly want to create one single place that everybody and everything can access, you can create an EFS, so Elastic File System. This file system can scale to whatever size and type. So similar as with EFS, we can get whatever size and we can have whatever performance, and data will be stored across AWS availability zone, so across AWS facilities. So again, you don't have to worry about losing your data. It's replicated across different AWS facilities in a given region. So that's what EFS. We've got this dynamic elasticity, so we can automatically scale. You're going to need to store more and more files. Don't worry, EFS can automatically scale the size for you. As we said, it can be simultaneously attached by thousands of EC2 instances, Lambda functions, container, also the on-premise instances as well. So it's truly shared file storage, and it's very effective, very cost effective. Because with EFS, you will only pay for what you've used. So do you store, I don't know, 15 gig of data, you'll pay for 15 gig. Do you store 2 tera, you'll pay for 2 tera, etc. So you don't actually have to like provision a size and then pay for it. No, AWS will only charge you for the actual storage that you're using. Okay, so that's the end of our storage section. So as you can see, we got plenty of storage services in AWS. Now let's move on a little bit because we've got another very interesting category of services. So now we're going to explore AWS database services. As always, I have to mention that we only unfortunately have time to talk about some examples from these categories, the most common services. When it comes to AWS database services, there's actually 17 different services currently offered in AWS. So again, fortunately, we don't have a couple days to discuss all of them, but don't worry, because we've selected the most commonly used services. So we've selected one from relational databases, so relational database service. We've selected one from non-relational family, so NoSQL databases. We'll be talking a little bit about Amazon DynamoDB, and of course, then we cannot forget, we cannot talk about databases without talking about a service that we can actually use to migrate databases from perhaps our on-premise facility to AWS. So lastly, we'll talk a little bit about AWS database migration service. All right, so the first service on the list was Amazon Relational Database Service. Again, commonly abbreviated as RDS. As the name suggests, RDS is a service that we can use if we want a relational database in AWS. I'm sure we all here familiar with traditional relational databases. They've been around since the 70s, the traditional database when we have tables. Inside the tables, we've got rows and columns. All the data, they have the same structures, and the data are related, hence relational database. So data between different tables are related one another. Typically, we're using primary key and foreign key, and this is the base for our relations. So if you want traditional relational database, you just want to use SQL, to get data from your database, etc. You want this familiar technology that you're most likely already using. But again, you don't want to do it yourself. You don't want to, get your own EC2 instance and install it yourself, patch it, update it, security scale, etc., etc. Again, you want a fully automated service, fully managed service. Sorry, you want a fully managed service. So you want a service in which AWS will do all of that for you. Then Amazon RDS, that's the right one to choose from. So RDS, with RDS, you'll get a fully managed relational databases. So all of these typical administrative, time-consuming tasks, and there's actually quite a lot when it comes to administration of your databases. Usually you need like a team of people to just do the admin work. Fortunately, all of that can now be done by AWS. Again, you can get the type, size, and shape that you want. So, whatever performance that you want from your database, whatever size you want, you can absolutely get it. It will be very, very secure. And since most of these tasks are automated, most of the admin tasks are performed by AWS, from admin perspective, it's super, super easy to use. Essentially, to get a database, it's a few clicks in the web interface, and in a minute or two, you'll have your database. Very, very easy. With RDS, you can actually choose from 6 different database engines. So if you want some of the most popular open source engines like Postgres, MySQL, MariaDB, you can absolutely do that. I know a lot of customers are transitioning to these open source technologies because, well, they're much, much cheaper. If you want some of the popular commercial databases such as Oracle or MS SQL Server, you can absolutely have it as well. And if you're curious, what is this Amazon Aurora? What is this doing here in the list? Essentially, Amazon Aurora is the database engine that was created by AWS from the scratch. So this is the database engine that's been created with cloud in mind. So database engine that could, truly utilize all the benefits and all the possibilities that the cloud brings. This engine is actually compatible either with Postgres SQL or with MySQL. So if you want to use Aurora, you can actually choose the compatibility mode. Either you have it with PostgreSQL or MySQL compatible. And now you're going to get this AWS engine, which according to benchmarks, it's 3 to 5 times more powerful than just plain PostgreSQL or MySQL. So essentially, you're going to get commercial support. You're going to get a performance from the commercial databases for just small percentage of the price than you would have to pay for even the open source databases. So kind of like an interesting mix of what world you're going to have the performance of commercial databases, but you will be actually paying even less than you would pay for open source databases. So if you're not familiar with it, I believe this is the AWS fastest growing service, actually, Amazon Aurora. So definitely check it out. Very, very interesting. When it comes to provisioning databases, it is very easy. It's very similar to EC2 instance, just a few clicks in a management console, and in a minute or two, you get your database instance. Getting a single database instance could be potentially problematic. As you can see, it's a single database instance. In IT, everything crashes all the time. So if you only have a single instance, if that crashes, perhaps your entire application can go down. That's why AWS offers a feature which is called multi-AZ deployment. So this multi-AZ deployment is actually a feature of RDS databases. And what it means, if you choose to turn it on, so one checkbox, if you click on that checkbox, then AWS will create a replica. So it will create a standby replica in a different availability zone. So now let's imagine this is AWS region. We've got availability zone 1, availability zone 2. Now your database, so this is our database, has been provisioned in availability zone 1. If we use the multi-AZ deployment, AWS will create the replica. It will create a replica in a different availability zone, so different AWS facility, and it will continuously replicate the data from the primary database to this standby replica, which is fantastic. So we have a replica in a different database, and everything is simultaneously replicated. Now, the good thing is, if something were to happen with your primary database, so imagine that your primary database goes offline, for whatever reason it might be, it just goes offline. Now, your standby replica will be automatically promoted to be automatically promoted, and it will automatically take all of the traffic. So from the application perspective, there's absolutely nothing to do. AWS will actually do this failover automatically, so you don't need to change any database endpoint. You don't need to wake anybody in the middle of night to do anything. Now everything will continue working. Just this standby replica will now take over and be your database. So really, really great feature. So as you can see with this feature, we can accomplish high availability, fault tolerance, and great level of reliability. This feature is not used for performance. This feature is only used for this high availability and fault tolerance. If we actually want to get more performance, if we want to get more read performance, we can create read replicas. Imagine that you have very read-heavy workload. You have some super complex, SQL queries that takes, days to be evaluated. So if you have very read-heavy workloads, you can create multiple read replicas. So now your primary database instance can stay there, and you can use, all of these read replicas that you've created for these read-heavy workloads. So multi-SE deployment and read replica. Okay, so that was a bit about relational database. Now let's take a little sneak peek into other huge family of databases, which are non-relational or NoSQL databases. As the name suggests, it's a NoSQL database, so we will not be using SQL, but we're using anything else. Typically, we're using some sort of like a JSON or JSON-like documents. There are 16 different non-SQL AWS database services, but the one I definitely want to talk about, probably the most popular one, again, one of the most popular AWS services, so maybe you've heard the name before. It's called Amazon DynamoDB. So Amazon DynamoDB is a key value, so it's a NoSQL database that offers, and this is quite interesting, out of the box, single-digit millisecond latency at any scale that you want. So this is absolutely fantastic. Essentially, if you're looking for a database solution that is going to be super, super fast, I mean, out of the box, single-digit millisecond, that's amazing. If you actually need even more, if the millisecond world, it's not good enough for you, you need to move to the microsecond world, so order of the magnitude lower. You can actually use the fully managed cache, which is called the DAX. And with the DAX, we can, sorry, we can actually move from the single-digit millisecond latency even to the microsecond. So we can have extremely powerful solution. And probably the biggest beauty about this solution, this will typically be much cheaper than the traditional, relational databases that you're using. So if you're looking, if you're building a modern application, if you're building web application, if you're building mobile application, if you're building anything cool, if you're building application and if you require very fast access to your data, also if you require very little cost, if you want to save as much money as possible, then you should definitely consider DynamoDB for your database solution. Again, DynamoDB is a fully managed service, so all of this management, patching, updating, scaling, that's all done automatically. In addition to being a fully managed service, DynamoDB is actually also serverless service. So with DynamoDB, we now don't have to choose like a database instance, certain type and size. DynamoDB will scale automatically based on your usage. You have little usage, that's cool. You have a lot of requests per second, that's fine as well. DynamoDB will automatically scale based on your usage, and you will always only pay for what you've actually consumed. So kind of like similar like a Lambda function, scales automatically. You only pay for what you've used. Again, here, DynamoDB scales automatically, and you've only paid for what you've used. So any kind of internet application, web application, mobile application, any kind of modern workflow, definitely consider DynamoDB for database service. So a couple of use cases, as we said, anything new, anything modern, any mobile application, web application, that's fine. Maybe some IoT devices, that's fine as well. In a gaming world, that's very commonly used as a backend, like a mobile backend. Again, very, very commonly used. We could probably find other examples as well. So DynamoDB, again, one of the most popular NoSQL databases. So if you're not too familiar with it, definitely check it out. I'm sure you will appreciate its features. So if you're excited about some of these database technologies, as I said, there are additional database services. So if you're looking for a graph database, you can find it in AWS. If you're looking for a document database, you can find it in AWS. If you're looking for quantum ledger, so like a blockchain database, you can find it, etc., etc. So you can find many additional database solutions. So if you're happy with that, if you actually want to start using databases in AWS, and you need a service that can help you to actually get over to AWS, so migrate data from your current solution to AWS. There's one great service we have to talk about, which is called Database Migration Service. So the database migration service can help us very quickly, securely, effectively migrate from your current databases, regardless whether it's in the on-prem environment, different cloud provider, wherever it might be. So you can very easily migrate from your current database solution into AWS. If you're migrating kind of like from same database, from same engine to the same one, like from, let's say, from Oracle to Oracle as an example, it is very easy to use. You can do that. If you also want to change the schema, let's say you're not happy with the paying expensive licenses anymore, so maybe you want to migrate, let's say, from Oracle to Amazon Aurora as an example, you can absolutely do that as well. There is an additional tool that you can use together with the DMS. It's called Schema Conversion Tool, or SCT, and this is the tool. So now we have two services used together that can help you with these heterogeneous migrations. So if you want to change the database engine from whatever to whatever, we can use the SCT to do that as well. The biggest beauty about using the DMS that we can either do this like a one-time migration. So how would it work? I would stop all the traffic coming to the source database. I will migrate all the data to the new database. I would change the application to use the new database instead, and I would start the traffic again. So this is this one-time migration, or what we can optionally also do is this ongoing replication. So AWS will do this one-time migration, and then it will keep on replicating any changes made to the source database. So you can actually have both of these databases in sync. This is very good because usually the migration process, one of the requirements is to have as little downtime as possible. Nobody wants to have their applications offline for a long period of time. So fortunately, with these DMS tool, we can accomplish these database migrations with a very, very, very little downtime. Okay, so now we've talked a little bit about compute services, we've talked about storage services, we've talked about database services. What we have in front of us right now are some of the AWS network services and content delivery services as well. So this is the agenda for the next module. When it comes to networking services, we definitely have to, start any networking discussion with Amazon Virtual Private Cloud. This is essentially the service that we will be using to create our own network in AWS. Then we'll be talking a little bit about Amazon Route 53, which is AWS DNS. So if you want a DNS, if you want to, let's say, buy a new domain, or if you just want to do the DNS translations, we can use Route 53. We also have AWS Direct Connect, which is actually a physical cable that will connect your own router and AWS router. So now you have a dedicated private connectivity to AWS Cloud. So if you don't want to use internet, to connect to AWS, but you want your own physical cable, you can get it as well. Then we'll talk a little bit about Amazon CloudFront, which is a CDN. Essentially, it's a service that we can use to cache content close to our users. So when our users are accessing our products and services, they can do it much faster. And lastly, we mentioned a little bit about AWS Transit Gateway, which is kind of like a central networking hub in AWS. So in the past, we had to configure many individual services in many places. Now we can just use one service to connect absolutely anything with anything else. So kind of like a networking hub for all of our needs. All right, so let's get to it. As we promised, we're going to begin with Amazon Virtual Private Cloud. So with Amazon Virtual Private Cloud, you can create your own network inside AWS. So if you want to create your own network, you want to use your own IP address, you want to then segment your own network into smaller pieces, you want to put some firewalls in place, to protect the network, either the border of the network or even the smaller individual components. You can do all of that by creating a VPC. So essentially in AWS, you can create your own VPC, your own network, and then after you've created your own network, you can start provisioning resources inside. For instance, the EC2 instances we've already talked about always have to be provisioned somewhere. So create a VPC first, and then you can provision your EC2 instances in your own network that you've created. You actually have a full control over your network. So whatever IP addresses, IPv4, IPv6 you want to use, whatever smaller segments you want to create, whatever route tables you want to create, other network gateways and devices you want to create. Do you want internet connectivity? You do not want internet connectivity, etc., etc., etc. So you have a full control over your network environment. So VPC, creating VPC is very easy. By the way, if you have your own AWS account, if you open a brand new one and you go to the VPC, you will actually see one VPC created for you. So every AWS account starts with a default VPC. This is just, AWS wants to make your life a little bit easier. Whenever you brand new, you already have a network to provision into. Obviously, you can keep using this network, or you can create your own network according to your own environments. I'm sorry, according to your own requirements. So this is essentially how it's going to look like. So we're now in our AWS account. We've selected AWS region. So the VPC will always be created inside a single region. So whatever region you want to create VPC, whatever region you want to create a network in, just select the region. Then you can create a VPC. So this is your own network with your own IP address that you want. And inside your own network, you can create something which is called subnet. So essentially, you can imagine the subnet as like a segment of your network. So how does it typically work? You create a VPC, you create a network with a big chunk of IP addresses. And now from this big chunk of IP addresses, you're going to take a smaller part and you're going to create a subnet, so like a segment of your network. You're going to take another chunk of the IP addresses and you're going to create another subnet, so another segment of your network. As you can see, since you have a full control over all of these networking components, route tables, etc., for some of these subnets, some of these segments of your network, you might want internet connectivity. So you can create something which is called public subnet. So we'll have a direct internet connectivity. So your customers can directly connect to your resources there. If you have like a web server that your customers need to access, that's good. However, other components, other segments, you might not want that. You want isolation from the internet, so you can create a private subnet, maybe to provision databases, backend resources like that. Of course, maybe you want some connectivity to your corporate environment. That's absolutely fine. But in these private subnets, you do not have this direct internet connectivity. So there was a little bit about networking. Now, if you want a DNS, so if you want a service that will translate the domain name, so if you own, let's say, example.com, somebody types example.com in a browser, now you need a service that will translate this name into an actual IP address of that resource. So if you need a service for that, so DNS service, look no further, we've got Amazon Route 53. So Route 50, highly available and scalable DNS service. With Route 50, so that's the DNS. So the primary functionality is going to be this translation between the domain names and the IP addresses. Also with Route 53, you can purchase your own domains. So if you want to buy, a domain name for your company, I don't know, example.com, whatever it might be, we can do that as well. Route 53 will also do the health checks. So if your infrastructure is running on a different resources, some of these resources could become unavailable, unhealthy. Route 53 will not route users to the unhealthy resources. So we've got health checks as well. If you already purchase your domain and your domain is registered elsewhere, you can actually transfer your domain to AWS. You can buy new ones, and you can ensure that this DNS translation will always work. Route 53 actually is one of the few AWS services that offers 100% SLA. So AWS is very, very, very confident that the service will always be up running. This is again due to the replication across all of the different facilities around the world. So AWS is fairly confident in the service. So you can also be fairly confident that your customers can always reach your website and your web application. So your customers can always consume your products and services. So essentially, this is how the DNS works. You do not want to give your customers IP addresses of your server, but you want to give them the nice domain names. So the customers, writes down the domain names into the web browser. Now that request will eventually reach Route 53. Route 53, I will return the IP address of that particular resource, and the customer will access that particular resource on that particular IP address. So this is essentially the DNS resolution 101. Now, there are a couple other networking services. By default, probably you're going to be accessing Cloud AWS using the internet. However, as we said, if you do not want to depend on the internet, if you actually want your own private cable that will be put in place between your own router and AWS router, you want to have this dedicated performance that you're paying for at your own. It's your own cable, so it's only for you. So it's only to connect your own router and AWS. No other AWS customer will be on it. You can actually get it, and the name of the service, it's called AWS Direct Connect. So private, dedicated connection between AWS facility, AWS router, and your own facility. Another networking service, it's actually a CDN, so Content Delivery Network, and it's called Amazon CloudFront. So Amazon CloudFront is the service that's actually utilizing all of these 500 plus AWS points of presence, so all of these 500 plus edge locations, and you can actually use any of these 500 plus edge locations to hash content in this location. So now when users are accessing, your applications, your services, the data doesn't have to be transferred, all the way from that origin. So all the way from that, let's say, an EC2 instance that could be in a AWS region, thousands of miles away. Obviously, that data transfer is going to take some time. But if the content is locally cached, in that edge location that's only maybe like a mile or two away from the customer, as you can imagine, the speed performance is going to be, so the user experience is going to be much greater. So if you want to utilize all of these 500 plus edge locations, just turn on CloudFront. The CloudFront is integrated with other AWS services. So it is actually very easy to put in place. Only takes like a minute or two to configure this service. And from that moment, you can start utilizing all of these 500 plus locations. A nice thing about the pricing, you will actually not pay for the data transfer between the origin place, so let's say EC2 instance or S3 bucket, whatever it might be, and the CloudFront. So that part of the journey, AWS will not charge you anything. So with Amazon CloudFront, again, this is the on-demand service, so you can turn it on anytime, you can turn it off anytime. There's no upfront charges, no commitment, and AWS will only charge you what you've actually used. So this is how it's going to look like. This is how CloudFront can make things much faster for us. Imagine that you have a web application and the original content, you have maybe like a web application that show users like video files, and all of these video files are stored in S3 bucket, let's say in Sao Paulo region, because maybe that's where you're based in. All right, that's cool. So if you have customers, around Sao Paulo, everything's going to be awesome. Everything's going to be very fast. But it's a web application, so maybe you have actually customers from all over the world, not only from Brazil, but customers from all other countries. So now imagine that you have a customer that's somewhere, I don't know, somewhere in China, or where is this? Maybe Japan. Now, obviously, the data transfer between the Brazil and the location of the customer, it's thousands of miles away. I know it's internet speed of light, but still, it's going to take some time. Fortunately, if you actually add CloudFront to your architecture, so now you can have access to all of these edge locations. There is actually going to be an edge location very close to your customer. Most likely, if your customer lives in like a bigger city, most likely there's going to be location right inside of that bigger city. So the content can be actually locally cached into these edge location. So now the customer, the content doesn't have to be transferred, all the way from Brazil, but the content will be only transferred that last mile, so between that edge location and that end user device. So the distance is much shorter. Shorter distance, it means much faster performance. So that's how Amazon CloudFront can make things much cheaper. All right, so I know we've talked a lot about compute, storage, database, and networking. What I have right now is a little knowledge check about these areas. So first question, you can do the knowledge check on your own. My first question is about compute. There's an AWS service that automatically distributes traffic across multiple targets and across multiple resources and availability zones. And we've got three options: elastic load balancing, auto-scaling, and AWS Lambda. If you recall correctly, is the first one, it's the Amazon elastic load balancing. So Amazon Elastic Load Balancing, this is that single point of contact. We send all the incoming traffic into it. Now the Elastic Load Balancing very commonly will be used together with EC2 auto-scaling. And now EC2 auto-scaling will be responsible for adding additional instances or removing instances based on the demand. So that's why we have the combination of these two services. They're greatly integrated with one another. So something we use very, very common together. The last option here was AWS Lambda. So if you remember AWS Lambda, this is the AWS serverless compute service. All right, so moving on. My second question. Amazon EC2 is a service that provides highly scalable, high-performance container orchestration. So container orchestration, was it EC2? It wasn't, right? So for container orchestration, it wasn't EC2, but very, very similar. It was called ECS. So EC2, this is that web server. So this is that virtualized web server that we can get on. We get an EC2 instance, any operating system, any type, any size, etc. And ECS, this was that container orchestration software. So with ECS, we get a fully managed Docker containers. All right, awesome. So next one, I have a question or a couple of questions about storage. So if you remember, we're talking about one AWS service, which was the best for high performance block storage. So you want a block storage, you want this like a virtual hard drive for your computers. We've got EBS, EC2, and S3. So if you remember, it was EBS. So EBS, this was this elastic block storage. So this was this virtual hard drive. We've already talked about EC2 instance. So this is that virtual web server. And we also have Amazon S3. If you recall, Amazon S3, this is that object storage service. So with S3, we create the buckets, and then we can store an unlimited number of objects inside these buckets. So that's what S3 was for. Okay, moving on. Another question about storage. So Amazon Elastic File System can only store data within a single availability zone. What do you think? True or false? Does it only single availability zone or perhaps multiple availability zone? So if your answer was multiple availability zones, so false, you're definitely right. So EFS can store data across availability zone. And then if you remember the difference between EBS, so that block store, and EFS, EBS, it's only for data that's attached to one instance at a time. With EFS, EFS can be potentially attached to thousands of instances, perhaps some on-premise resources, perhaps a Lambda function, perhaps containers, etc., etc. So EFS can be simultaneously attached by multiple resources at the time. All right, a couple questions about databases. So my first question would be about database service that's great, or database option that's great for NoSQL databases and also serverless. So I'm looking for NoSQL serverless databases. What do you think? Is it DMS, DynamoDB, or RDS? So if your answer was DynamoDB, you're correct. So what do we have in here? Amazon RDS. RDS, this is a relational, so this is SQL database, and it's also based in server, so we have to create an RDS instance. Then we have AWS DMS. This was that migration service, so if you want to migrate databases. And lastly, so the correct option is the DynamoDB here. So with DynamoDB, we can create NoSQL serverless database. Awesome. So another question about databases, one last question about databases. Now I'm looking for AWS service to support multiple database engines such as Aurora, MySQL, PostgreSQL. If you remember, there was also Oracle, MS SQL Server, and MariaDB. So which one do you think it is? RDS, Lambda, or 3? Again, if your answer was RDS, you're definitely correct. So RDS, this is the relational database service that supports the 6 different database engines that we've talked about. All right, and now I've got the last 2 networking questions. So my first networking question is about AWS service that is highly available, scalable DNS. So I need the DNS, I need service that will translate these domain names into IP addresses, vice versa. And also I need a service that will allow me to buy new domains or potentially migrate already existing domains into it. Which one do you think it was? VPC, Route 53, or Direct Connect? So if your answer was Route 53, you're definitely correct. So Route 53 is the AWS fully managed DNS service. We have here the Amazon VPC. So the Amazon VPC, that was the actual network that we can create inside your own AWS account. And now you have full control over the network. And also here we've got AWS Direct Connect, and it was that physical cable that will connect AWS router and your own router. So you have this private dedicated connectivity to AWS. All right, and the last question that I have here, also about networking, and I'm looking for a fast content delivery network. So I'm looking for a CDN network. It's Direct Connect, S3, or CloudFront. What do you think? So again, for one last time, if your answer was Amazon CloudFront, you're correct. We've already talked about Direct Connect, which is that private cable. S3, this is that object storage service. So we create bucket, store unlimited number of objects. And we've got Amazon CloudFront, which is that CDN. So remember, with CloudFront, you have access to all of these hundreds of these edge locations, and we can use any one of them to cache content, so the content is delivered much faster to our customers. All right, so this is the end of a little overview of the most important AWS services. Don't worry, there's still a lot of things to talk about. We'll be talking about security, we'll be talking about shared responsibility model, and more and more and more. So there's still plenty of stuff to talk about. However, before we do that, again, we ran for almost an hour again. So why don't we take a little break? Let's say it is 11:33, 35. So why don't we come back at 11:45 Eastern time? So if you're in a different time zone, quarter to whatever it might be to. So it is exactly 11 minutes from now. So 11 minutes break, and be sure to join us. We still have, a lot of really cool things to talk about. So enjoy the little break, get some refreshment, and make sure to join us in 11 minutes. We still have a lot of cool things to talk about. So thank you for now, and hopefully see you all very shortly. Okay, hello and welcome back, ladies and gentlemen. Thank you so much for joining us for the last section. I think the last section is actually probably the most important section of our entire webinar. I mean, it is, absolutely amazing that we have access to all of these products and services. It is amazing that you can get pretty much as many IT resources as you want, and you only one click of a button away, so you can get absolutely anything anytime. However, if you want to get all of these services, if you need to use all of these services, obviously what you should probably do at the first place is make sure that everything is secure. So regardless whatever you do in AWS, regardless whatever product or service you're using, or whatever your job might be, anybody that has anything to do, anybody that has, anybody that comes anywhere close AWS should do their job in a secure manner. So that's what we have for the remainder of our seminar. We'll be talking about security. We'll be talking about, how can we operate in a cloud, how we can utilize all of these benefits and advantages in a secure manner. So security, what is security? There are plenty of components to security. Obviously, security is about visibility. Security is about, knowing what's happening, what's going on inside your AWS account. Security is also about auditability. So anytime anybody or any application does anything, all of that should be logged. So we should have a history of all the changes, all the actions that have happened in your AWS account. Security is also about controllability. So we need to be able to control our resources. We need to be able to control, who does what, who's got permission to do what activities. And the last one, I know sometimes security is being thought about as like a limiting factor. So yeah, there are all of these security rules, so I cannot do my job well. I have to, wait forever for some approvals, etc. So security should also be about agility. We need to be able to utilize this, all of these benefits that cloud brings us. We cannot be constrained, by some security rules that make no sense. So whatever security we put in place, always think about to do it in a way as limiting for the users as possible. When it comes to being in a cloud environment, probably you are asking, well, okay, so we've got a cloud environment, so AWS will do something for me. We have different services. Some services, AWS is responsible for a little bit more, and other services we are responsible for a little bit more. So how do we actually know who's responsible, who's expected to do what? So any questions you might have around the responsibility, who's expected to do what, you can answer all of these questions using shared responsibility model. So the shared responsibility model is the model published by AWS that clearly defines a responsibility between the cloud provider, AWS, and us as the cloud customer. So this model will obviously differ per service. Some of the services, some of these more managed services like AWS Lambda or DynamoDB, AWS is responsible for quite a lot. It's a managed service, so all of this managing, patching, updating, securing, scaling, all of that is handled by AWS, while other services, maybe like an EC2 instance we've talked about, we're responsible for quite a bit. Essentially, anything from the OS level up, so all of this patching, installing, updating, now it's us who's responsible for that. So this model will differ per service. So obviously, whichever service you're thinking about, find a particular model for that specific service. However, in general, we will be always responsible for security in the cloud. So whatever services you've provisioned, whatever configuration that you make, whatever data you've put in, essentially whatever you did yourself, you will always be responsible for that. And AWS will always be responsible for security of the cloud. So security of the cloud as the cloud platform. So all the way, from these data center, physical security, hardware security, software, network, virtualization, all of that. So AWS will always be responsible for security of the whole platform. Obviously, AWS won't leave you hanging. There are plenty of security services that we can use. Other security services that we can use to configure access to AWS. Other security services that we can use to, scan for viruses, scan our workload for some potential unwanted software. There's services that we can use to protect our infrastructure, services that we can use to protect our data, and lastly, there are services that can help us with the compliance. So if we're bound by certain laws, compliance standards, etc., again, there are security services that can help us with that. So why don't we take a look at some of these security services? The first big category was the identity and access management. So these are the services that can help us to create identity, create accounts, associate appropriate rights, and make sure that people and application only have access to part of the cloud that you desire. In here we have services, probably most important here, which we'll actually be talking about a little bit later, is the identity and access management, or IAM. So this is the service that we can use to create our users and associate appropriate rights. So by default, we start with 0. By default, nobody has any access to AWS. We have to create users first with unique credentials, and then we have to explicitly grant them access. So we start with 0, and we have to explicitly say, okay, so you can access this and this, you can access that. We can be very, very, very granular when we're saying who can access what. We also have other services here. For instance, what customers very commonly use is the combination of AWS directory services and AWS single sign-on. So directory services, if you already have some sort of directories like Microsoft Active Directory, something like that, and already using that to provide access to your company network, you don't have to reinvent the wheel and recreate everything again. You can actually connect your environment with AWS, hopefully also, or potentially also with the SSO, so you can provide very easy access to your employees. Don't have to recreate all new users, etc. You can connect the existing world. We also have AWS secret managers. We also have AWS secret managers for managing all of the application secret credentials, etc. And if you're curious about Amazon Cognito, this is pretty much the same identity management as we were talking about, but this time it's not for our AWS account, but it's the identity management for your own application. So if you want if you have a web application, mobile application, and you again don't want to think about, okay, how to create like new user registration, forgot password, all of that, even the visual components, you can get all of that out of the box using Amazon Cognito. When it comes to detective control, there are plenty of really good services that we can use. For instance, we've got AWS Security Hub, which is a unified security and compliance center. Essentially, as the name suggests, Security Hub, it aggregates all of the other security services in a single place. We have Amazon GuardDuty, which is a fully managed threat detection service. So Amazon GuardDuty can continuously scan your AWS account, your workloads. Can continuously keep an eye out, who's doing what in your AWS account, and if it finds something suspicious, like some maybe suspicious logging attempt from a country that you usually do not log in, etc., things like that, it can notify you. We also have Amazon Inspector that can scan your workloads. So if you want to scan your EC2 instances, etc., for some viruses, we can do that. And last one, we've got a really cool service which is called Amazon Macy. It's a fully managed service that can help you identify potentially sensitive information across all of these different storage services we've talked about. And should it find maybe somewhere, dig down in the logs that you have like a credit card number or something like that, again, you can be notified and you can take appropriate action. Next category was the infrastructure protection services. These services are absolutely amazing when it comes to protecting your infrastructure from the common threats that you can find out there in the internet. So essentially, anytime you have any internet-enabled workload, any website application, whatever it might be, anything that's out there on the internet, as you know, there are a lot of threats out there, but fortunately, AWS can help us mitigate these threats. So we've got AWS Shield, which is a fully managed DDoS protection service. We've got AWS Web Application Firewall, which is a firewall that can help us to filter any kind of malicious web traffic using great intelligence from AWS. And last one here, we've got AWS Firewall Manager. Again, this is kind of like a service that we can use to centrally coordinate all of these different rules, etc. So if you have a lot of AWS accounts, a lot of different services, again, you can have one place that you are going to use to centrally coordinate all of your infrastructure protection. Now, the last category was almost the last one, it was the data protection. So in here, we've got services such as KMS, which is the service that we can use for encryption, encryption at rest. So anytime something is stored in AWS data center, if you want to have that encrypted, regardless which service it's actually used for, the actual storage, we can use KMS for that. If you have a higher compliance requirements when it comes to controlling the keys that are used for encryption operation, etc. So if you have higher regulatory compliance requirements, we can use Cloud HSM. And we also have encryption in transit. So if you want to use HTTPS, not just HTTP, so you want to encrypt all the information that's being transferred between AWS and your customers, we can also use AWS Certificate Manager. And the last security service that we've got in here, this is the security service that can help us with compliance. So with AWS Artifact, we've got on-demand access to all AWS compliance reports. So as you probably imagine, AWS has been audited by pretty much all the auditors that are out there in the world, different countries, different requirements. If you need an access to all of these reports, you have it at no cost. Just go to the AWS Artifact and you can access all of these different reports. So that, ladies and gentlemen, was AWS security in a nutshell. As I said, we only have a couple hours today, so I try to tell you as much as possible within the time period. Of course, if you're interested more about security, then look further into some of the dedicated resources for security. Obviously, there's so much more to talk about all of these different services. What we're going to do now in the remainder of our time, we're going to talk a little bit more about one of the security services we mentioned, which is IAM. So IAM is the Identity and Access Management. This is the service that we can use to manage access to our AWS resources. As we said with AWS, we always start with 0. So when you open the AWS account, you only have one set of credentials for the super admin. It's not really recommended to use these credentials for common, day-to-day tasks. Well, it's actually recommended only use these credentials that will be given to you by AWS for the very first login. Then after you log in, you can create IAM users and roles. So you can create IAM principals, and from that moment on, only use your created IAM principal. And to do all of that, to create all of these different, accounts for all of these different people and application, etc., you can do it from one central place. You can do it from IAM. Also with IAM, we have access to additional security features such as MFA, multi-factor authentication. Obviously, always recommended, available at no additional cost. You will add additional layer of security. So anytime somebody needs to log in, now you have to, in addition to username and password, you need to input this one-time password generated by either hardware devices, these like gem alpha tokens, or some virtual devices like the app in your phone. So a little bit about IAM and the terminology. In IAM, we'll be creating IAM users. IAM users, very simple, is an entity that we create to represent a single person or a single application that will be interacting with AWS. For instance, I'm Tomas, so we can create IAM user Tomas. If there is another requirement, for instance, we can create IAM user John, IAM user application one, etc., etc., etc. So we should never, share credentials. IAM users are created for one single person or application that will be interacting with AWS. By the way, the IAM users by default have no permission. So whenever we create a brand new user, we'll be given credentials. You can use the credentials to log in. And when you log in, you can do absolutely nothing. So by default, there are no credentials. We have to explicitly say what this user can do and what that user can do. Obviously, if you're a very small company, 5 people working, it's super easy to do. If you're a bigger company, from the management perspective, it might be a little bit harder. Fortunately, we can also create IAM groups. Very simple. A group is a collection of users. We can create, let's say, group developers, put 25 different developers, 25 different individual IAM users that we have into the group. And now we can manage permission on a group level. So from a management perspective, a little bit easier, since all of these developers should have the same permissions or similar permission, much easier to manage the permission on a group level rather than doing this individually. So this is essentially how it's going to look like. We're inside an AWS account. Imagine that we've created 2 IAM groups. So we've got IAM group admins, we've got IAM group QA, and then inside of these groups we'll have multiple IAM users. So all that John, Sophia, Matteo, and John again, these are IAM users. As you can see, a single user, for instance, John here is the same John. So a single IAM user can be member of multiple groups. Now, as we said, by default, we start with 0. So by default, nobody has any permissions. If we want to fix that, if we actually want to allow, some users to do something, we can create IAM policy. So IAM policy is simply a document, JSON document, that will specify exactly the permission that will be granted to a certain entity. So essentially, we just have to write the document. We say, okay, so maybe you have like read-only access to S3. Maybe you can create EC2 instances, etc., etc. So we have to list everything that the user is supposed to do. We can be very, very, very granular. We can be granular on the API level, so super, super granular. It's again recommended. So list everything that the user is supposed to do, attach the policy to the user or perhaps to the group, and it's up to us. And now the user or maybe all members of the group will have that permission that we've listed in the policy. By the way, the best practice here is to follow something which is called least privilege model. Essentially, people and applications should only be authorized to do activities they're supposed to be doing. I know sometimes, we're like very busy, don't have time to create a detailed policy, so we might tend to create something with like larger access that's easy to create. Never ever a good idea. Always follow the least privilege model. If somebody should only have read-only access to S3, that person should only have read-only access to S3. If another person should only have read-only access to one specific S3 bucket, then the person should only be able to read documents inside objects inside that single S3 bucket. So always follow the least privilege model. As we said, what's again recommended is AWS. What's also recommended is MFA. So MFA will add additional layer of security. As I said, both hardware devices. So if you're using these like Gemalto tokens, like little device, there's a button, you push the button, it generates the one-time passcode. If you want to use them, or if you just want to use software devices, they're like apps you can download to your phone, and anytime you log in, you'll be prompted to put this one-time passcode. You can use it at no additional cost. Again, absolutely recommended. Adds additional layer of security, which is always better. I've already mentioned the service, which is called AWS Artifact. So one more time, AWS Artifact is the service that will provide us the on-demand access to all AWS security and compliance reports. Also, if you have some private deals with AWS, you can also access your private deals with AWS in here. Again, as I said, there are many different industry standards, compliance frameworks, different countries, different laws, etc. So there's quite a lot. Again, if you need all of this information, go to the AWS Artifact. You can filter based on the country, territory, compliance report, etc., etc. And I'm sure you'll be able to find what you're looking for. Just to highlight a very few of these compliance reports, again, depending on the territory, maybe PCI compliance, HIPAA is your thing, GDPR in Europe, different ISO norms, etc., etc., etc. So all of this information can be found in AWS Artifact. So to sum up the security section, I've got a couple of questions about dividing the responsibility between AWS and customer. So if you remember, we've discussed this idea of AWS of this model that will divide responsibility between AWS and us, so shared responsibility model. And we've got a couple of questions to try to identify who will be responsible for what. So my first question is about configuring security group rules. So security group rules are virtual firewalls that determine which ports are open on the EC2 Linux instances. So it's an EC2 instance, it's something that we have control on. Virtual firewall, again, it's something that we have control on. So that's going to be our responsibility to configure appropriate firewall rules. Next one is about preventing packet sniffing at a hypervisor level. So this question is asking about hypervisor level. So somewhere in an AWS data center, AWS is running servers. In the servers, we've got hypervisors that are responsible for dividing the available capacity of the servers between AWS customers. So as you can see, it's a hypervisor. It's something that AWS has full control over. So this is going to be the AWS responsibility. Next question is about patching the operating system with the latest security patches. And again, imagine, for instance, EC2 instance. So again, EC2 instance, it's us who's responsible for anything that's happening inside. So from the OS level up, that's all our responsibility. So again, that's going to be us. Next one, it's about shredding disk drives before they leave a data center. So now again, AWS data center, sometimes, the products have to be decommissioned, they're not usable anymore. Obviously, any disk, so any products that could potentially contain some information will be well shredded according to all of these different guidelines, compliance with network, etc. There's actually some pictures how AWS does the shredding. If you see the results of the shredding, I wouldn't even recognize it was a disk anymore. So it's absolutely unusable. So this is definitely something AWS will do. Next one is about securing the internal network inside AWS data center. Again, we're inside AWS data center. So us as a customer, we have no idea what's happening inside AWS data center. AWS doesn't even publish the locations of the data centers. So that's full AWS responsibility. By the way, don't worry about it. As I said, AWS is still being audited by all the auditors out there in the world, all the famous companies out there in the world. So it's not a black box. If you need to assure that AWS is following all applicable laws, procedures, compliance standards, etc., just go to the AWS artifacts and you can access the reports from all of these independent third-party audits. And the last two things, the first one is about installing camera system to monitor physical data centers. Again, right, it's a data center, it's an AWS data center, so that's something for AWS. And the last one is about toggling on the server-side encryption feature for S3 bucket. So this time, that's something, toggling, configuring something. So whenever it's something about our configuration, our choices, that's our responsibility. By the way, actually, the last question, it's not really relevant because right now, all new created S3 buckets are encrypted by default. So all the server-side encryption, it's automatically on for all newly encrypted, all newly created S3 buckets. So now when you go to AWS account and create a new S3 bucket, it will always be encrypted. It's actually not possible to turn it even off. So everything now will be encrypted in S3, which is obviously a good thing. So one last question that I have is about IAM. So with your AWS account, you must create all of your IAM policies initially. What do you think? True or false? Must you or you don't have to? I've got a good news for you. You actually don't have to do it because AWS offers plenty, hundreds of these IAM policies out of the box. So for the most common use cases, most common situations, you can actually use a policy already created by AWS. What customers typically do, though, is use this policy as kind of like a starting point. So you take the policy created by AWS and then you fine tune it. So different customers, different requirement, but maybe the core, the most of it will be the same. So you just take the starting point and you just tweak it a little bit so it works, 100% for your expectations. So that's what customers typically do. All right, so ladies and gentlemen, to sum up the security section, obviously security is a big topic. We've only had, a couple of minutes to discuss security. So I would definitely encourage you, if that's something that interests you, to continue with your education, not only maybe with the security topic, but with any topic that's relevant to you. So whatever area you might be interested in AWS, compute services, database services, AI services, machine learning services, whatever it might be that you're interested in. There are plenty of resources to look for. There's the official AWS learning portal, which is called Skill Builder. So if you're interested in official AWS learning, the portal is for free, by the way. You can access over 500 individual courses for free. So I definitely have to encourage you to do that. Some of these courses are really cool nowadays. There's also games, so you can actually play a game and you can learn about AWS while playing a game. So you can find cool stuff like that. Skill Builder, that's the portal to look for. So that's the official AWS training portal. So, ladies and gentlemen, that's it. That's all of the agenda that we had for today. So thank you so much. I'm hoping that you've enjoyed the time that we've had together. I posted a link to the evaluation to the chat here. So if you have a couple minutes for the evaluation, it would be absolutely fantastic. There is a link over there. So you can please fill out the evaluation. Obviously, evaluation is always good. So I would greatly appreciate it. Also, if you want to stay in touch with me, if you have any other questions about me, about anything from the AWS world, I'll be super happy to talk to you about them. Probably the best way, the best platform is LinkedIn. So there's the QR code that's linked to my LinkedIn profile. And feel free, to send me any questions, thoughts, or anything that you have over there. I'll be super happy to hear from you there. I'll make sure, even if I don't know the answer, I have a lot of colleagues in AWS, so I'll make sure that somebody will get to. So ladies and gentlemen, thank you so much. That's it from me. I'm hoping that you've enjoyed today's webinar. There are also other webinars today, so if you haven't signed up for other ones, there are also plenty of other webinars for today that you can sign up for. They're really, really cool, so strongly encourage you to do that. So with that being said, thank you so much. One more time, I'm hoping you enjoyed it. Have a fantastic rest of the day. Maybe see you in a different webinar or see you somewhere else in the future. Thank you so much. Goodbye and take care.